All right, guys, welcome back. We're still continuing with the series of calculus first principle differentiation. Okay, we are still working with the very same question, but now the difference is the function keeps getting more and more and more abstract. So this is the function that we have now.
Asifuni ukusubscribe.
Here we are given f at x is equal to 1 over square root of x, and we are going to determine f prime of x by use of first principle. First principle, guys, will always be provided to you on your formula sheet behind the paper. That's where the formula sheet will be provided. So here is the formula that you'll be using. F prime x is equal to a limit as h tends to 0, f into x plus h minus f at x all over h. This is the formula that you'll be using whenever you see the term says first principle. Okay, I want you guys to score as much marks as you can in these questions. Okay, so here, in order for you to even try to take the question, you have f at x is equal to 1 over square root of x. So the first thing that you have to find is f into x plus h before you even go for a solution. So that one becomes 1 over a square root of x plus h. Here is the solution. Solution. All right. So here we are working with that equation, that formula that says f prime of x is equal to a limit as h tends to 0 into f at x plus h minus f at x all over h. So from here, I know that f at x plus h is 1 over a square root of x plus h, because I did found it previously, minus 1 over a square root of x over h. Okay, from there, a limit as h tends to 0. So what am I going to do? LCT should be square root of x plus h. Okay, so here it should be just a square root of x minus a square root of x plus h. And then I divide by h, right? A limit as h tends to 0, and then I rationalize here. It should be a square root of x minus a square root of x plus h over a square root of x times a square root of x plus h, and then I multiply by 1, and my 1 will be a square root of x. Okay, it's a square root of x plus a square root of x plus h over a square root of x plus a square root of x plus h. So this is my 1. I still have this h. So from there, a limit as h tends to 0 is now equal to, if I multiply the two, this one times this one, this becomes a difference of 2 squares, which gives x minus into x plus h all over a square root of x times the square root of x plus h into a square root of x plus the square root of x plus h. All right. Remember, we still have this h. So when I get rid of this bracket, a limit as h tends to 0 is x minus h over. When I multiply these two, I get x square root of x plus h. And when I multiply the two, I get plus a square root of x times into x plus h. All right, I can rewrite, I can then multiply by 1 over h. So dividing by 1 over h and multiplying by 1 over h, it's one and the same thing. So from there, x and x cancel. I'm now left with a limit as h tends to 0. Here I have minus h. So minus h and this h, they will then cancel, and I'll be left with minus 1 over here. It will be x times square root of x plus h plus a square root of x times x plus h. So if I choose to let my h to be equal to 0, this is what I will have. So if I replace h with 0 here, I'll be left with what? It will be x times square root of x, because this one will be 0. And then from there, if I replace h with 0, I'll be having what? Same as x, also square root of x. So as a result, I have minus 1 over 2x times the square root of x. Square root of x. Alright, if you can look carefully here, we have the multiplication of powers with same basis but different exponent. If you can look carefully here, because this can be written as, okay, we have minus 1 over, here is 2, of which is x times x to the power of 1 over 2. And this is same as minus 1 over, okay, minus 1 over 2. When I multiply the 2, I pick one base and I add the exponent, becomes x to the power of 3 over 2. This can be written as minus 1 over 2 cube root of x squared. This is a solution to this problem.
Yay! Subscribe, subscribe.